Mathematics is fun, you can do it. So hello everyone, welcome back to our channel. In today's video, we will be discussing about the fifth operation on functions, which is called composition. So let's get started. At this point, we are going to discuss the fifth operation of functions, which is called composition. Composition of functions. So it is also known as substituting one function into another. Okay, let's start. But before that, let's have a recall. We have here the sum f plus g, or functions f and g. So we will recall briefly the four operations that we had discussed before. So we have f plus g of x is equal to f of x plus g of x. This just says that find the sum of the two functions, add them together. So you should simplify by finding like terms. So you have given, if you have f of x is 2x squared plus 3 and g of x is 4x cubed plus 1. So if we are asked to find the sum of the two functions f and g, so we will just combine 2x squared plus 3 plus 4x cubed plus 1. So you will just combine like terms and put in descending order. So we will have 4x cubed, then copy 2x squared, 3 plus 1 is 4. So this is the answer. It's very easy. Okay, let us recall the difference of two functions considering f minus g. We have functions f minus g of x is equal to f of x minus g of x. So to find the difference between two functions, subtract the first from the second. We have here the quotient. Make sure you distribute the minus sign to each term of the second function. So you should simplify by combining like terms. So the same given, f of x is equal to 2x squared plus 3. Then g of x is equal to 4x cubed plus 1. So you have f minus g is equal to 2x squared plus 3 minus 4x cubed plus 1. Okay, minus the quantity of 4x cubed plus 1. So again, remember the quotient. Okay, don't forget, you have to take note that you need to distribute the minus sign for every quantity inside the parentheses. So you will have negative times positive 4x cubed, you have negative 4x cubed, negative times positive 1, that's negative 1. Then, arranging the terms in descending order, you have negative 4x cubed, then followed by 2x squared. Then we can combine 3 and 1, 3 minus 1, that is positive 2. Therefore, the answer is negative 4x cubed plus 2x squared plus 2. Let us proceed to recalling our product of two functions, f and g for instance. So f times g of x is equal to f of x times g of x. Okay? By the way, I would suggest that we will not use this symbol anymore. We will just use the dot at the center. That represents a multiplication sign. So to find the product of two functions, put parentheses around them and multiply each term from the first function to each term of the second function. So we have here f of x is 2x squared plus 3 and g of x is 4x cubed plus 1. The same given as the addition and subtraction. So f times g is equal to 2x, the quantity of 2x squared plus 3 times the quantity of 4x cubed plus 1. You have double this or double distribute. You have 2x squared times 4x to the power of 5 is 8x to the power of 5. 2x squared times 1 is 2x squared. 3 times 4x cubed is 12x cubed. 3 times 1 is 3. Okay, so it is a good idea to put in descending order but not required. Although not required, still correct if you are going to do this one. But I am encouraging you to arrange this one in descending order. Okay, so 12x cubed should come first before 2x squared. Okay, that's it. Now let us proceed to recalling on getting the quotient of two functions, f divided by g. So f divided by g of x is equal to f of x over g of x. Now to find the quotient of two functions, put the first one over the second. So you have f of x is equal to 2x squared plus 3, and then g of x is 4x cubed plus 1. Then f over g is equal to, you have 2x squared plus 3 all over 4x cubed plus 1. So nothing more you could do here. We could no longer reduce this one. We could no longer factor this out. So this will be the answer. Just retain it as it is. But if you can reduce this, you should. Okay? Now let us proceed. Now you have noticed that the first four operations and functions are pretty straightforward. So they are just very simple. Okay? The rules for the domain of functions would apply to these combinations of functions as well. Now the domain of the sum, difference, or product would be the numbers x in the domains of both f and g. For the quotient, you would also need to exclude any numbers x that would make the resulting denominator 0. Now we're talking about the domain. Okay? So now let us proceed to the fifth operation. We have composition of functions. So we have here the composition function, that is, this is now the symbol for the composition. This is read as f composition g of x is equal to f of g of x. Okay? And means to copy the f function down, but every time you see an x, substitute in the g function. So considering we have the same given, f of x is equal to 2x squared plus 3, and then g of x is equal to 4x cubed plus 1. So you have f composition g is equal to, you copy the first function first, which is 2x squared plus 3. And then, remember we have here x squared, as it is suggested that every time you see an x, you substitute the g function. The g function is 4x cubed plus 1. So this becomes, you copy 2, then x, the value of x now would be the whole function of g. So you have 4x cubed plus 1. So you will write it here. And since it's x squared, there must be an exponent 2 outside the parentheses. Then copy plus 3. Okay? So first double distribute, then multiply 2. Remember, you have 4x cubed plus 1 quantity squared, meaning we will multiply 4x cubed plus 1 itself twice. Okay? So that means 4x cubed plus 1 times 4x cubed plus 1. You will use the FOIL method or the distributive property. Then you multiply the result by 2. So you have, this is now the final answer, 32x to the power of 6 plus 16x cubed plus 2 plus 3. Then simplify this one, you have 32x to the power of 6 plus 16x cubed plus 5. Okay, I hope that this is clear. Now, what about if you have this one? We'll do the other way around. If g composition f of x is equal to g of f of x, we will have, this is read as g composition f and means to copy the g function down, but wherever you see an x, substitute in the f function. So g of composition f is equal to, since g of x is the first one that you can see here, that's the first function, you're going to write the whole function, 4x cubed plus 1. And every time you see an x here, we are going to substitute the f function. Okay? So we will write 4x cubed plus 1, and x will be replaced by the whole f function, which is 2x squared plus 3. And since it has 3 exponent, you'll write it 3 outside the parentheses. Then copy plus 1. Okay? So we will not show how are we going to simplify this one, but this is how we're going to do it. Meaning you are going to multiply this itself 3 times. Then multiply it by 4, then plus 1. Okay? As long as you understand the concept. Now, what about if it's like this? f composition f of x is equal to f of x, meaning we're talking about it only involves one function itself. So you have the given f of x is 2x squared plus 3. So remember, if you could not see the g function here, no g function here, so we're not going to include the g function. So we'll focus on our attention on function f, or f function. So f of x is 2x squared plus 3. We'll write 2x squared plus 3, and every time wherever we see x, we'll replace that with 2x squared plus 3. So it becomes 2 times the quantity of 2x squared plus 3, and since there's an exponent 2, we'll copy 2 outside the parentheses. Then you have plus 3. Okay? The same procedure, you are going to double distribute this one, or you're going to use the FOIL method, then multiply it by 2, then plus 3, and then simplify. Okay? Next, let's have more description on composition. Definition of composition of functions. The composition of the functions f and g are given by f composition g of x is equal to f g of x. F of g of x. So f composed of g or f composition g, they're just the same. Okay? There are steps in computing f composed of g of x. So you begin with the f function, plug the g formula in for x, complete the f formula, then reduce the equation. Now, a composite function is actually a combination of two functions. You apply one function to the result of another. The composition of the function f with the function g is written as f of g of x. So which is read as, you have here, f of g of x. It is also known as f composed with g, or f composition g, or f composed with g of x. Okay? So in other words, you have here f composed with g of x is equal to f of g of x. So, for instance, you have f of x is 2x plus 5 and g of x is x minus 3. You can work out a single rule by the composite function g of f of x in terms of x. So you have find f composed with g of x. You have g composed with f of x is equal to, we have here g. You copy first the, by the way, this somehow interchange. This is supposed to be g of x. Well, I'll change this one. I'll change this one. Okay, this is supposed to be g composition. It's very difficult for this one to do, but I'm just trying to make some corrections. Okay, so this is supposed to be g composition, composed with f of x. Okay, so I'm just making some corrections. So the solution suggests that we have g of f of x. So first is we're going to look at the given g of x function, which is x minus 3. So we'll have x minus 3. Then our x, since we have here g composed of f of x, composed with g composed with f of x, since we have here the g function x minus 3, and every time we encounter x, we'll substitute the value of our f, or the function f. Our f function is 2x plus 5. Therefore, we will have x minus 3. Then x will be replaced by 2x plus 5, which is our function x. Then 2x plus 5 minus 3, that gives us 2x plus 2. Okay, next. Do you think f composed with g of x will give you the same result? How about this one? Okay, the previous one is g of f of x, and the second one is f of g of x. That's the other way around. So do we have, or do we get the same result? What do you think? Obviously no. Okay, so you have f composed with g of x will be equal to f of x minus 3. So you have, we're going to copy, this time we'll copy 2x plus 5. Okay, 2x plus 5. Then we're going to substitute the value of our x with the g function, which is x minus 3. So you have 2 times the quantity of x minus 3 plus 5. So 2 times x, 2x. 2 times negative 3, negative 6. Then copy plus 5. Copy 2x, negative 6 plus 5 is 2x minus 1. Okay? So remember that g of f of x is 2x plus 2, and our f of g of x is 2x minus 1. So obviously they are not equal, or they're not the same. Okay, let's proceed. So let's try. How about this one? F of x is 2x plus 2. G of x is x plus 2 quantity squared. Okay, so find g composed with f of x, and also f composed with g of x. So we will have this one, we have g of 2x plus 2, because our f is 2x plus 2. So that would become the quantity of, we have here, since our g is x plus 2 quantity squared, for our x will be substituted by the function x, which is 2x plus 2. So you have 2x plus 2, then plus 2 quantity squared. Okay, so 2x plus 2 is 2x plus 4. Then quantity squared, we will have, okay, multiply 2x plus 4 by itself twice, or we can do FOIL method. So we have the resulting answer. We have 4x squared plus 8x plus 8x plus 16. Then combining like terms, you have 4x squared plus 16x plus 6. Okay, so let's do the other way around. We have f composed with g of x. So that becomes f of x plus 2 squared plus 2 is equal to, we have, so this time we will be writing this down, 2x plus 2. You have this one, 2x plus 2. However, our x, every time we encounter x, we will replace that with our g function, which is x plus 2 quantity squared. So we have it here, is equal to, we need to expand first x plus 2 quantity squared inside the parentheses. So that becomes x squared plus 4x plus 4. Then copy plus 2. Okay? Then after that, we are going to distribute 2. So 2 times x squared, 2x squared. 2 times 4x, 8x. 2 times 8, 8. Then just copy plus 2, then simplify. Copy 2x squared plus 8x. 8 plus 2 is 10. Okay? So I hope everything is clear so far. Let's proceed. You may need to evaluate a composite function for a particular value of x. Now this time, we will be dealing with a particular value of x after doing the composite function. Let's say f of x is equal to 5 minus 3x, and g of x is x squared plus 4. Find f composed with g of 3. Now this time, there is a particular value of x. So how are we going to do this one? Method 1, work out the composite function, then substitute 3 for x. So we can do this one. We can do the composite function first. Since f of g of x, we are going to write 5 minus 3x. Then every time we encounter x, we are going to plug the g function. So you have 5 minus 3x. Our x will be substituted by x squared plus 4, which is our g function. Then, you have 5 minus, you have here negative 3x squared, negative 3 times x squared, negative 3x squared. Negative 3 times 4, that's negative 12. Negative 12 plus 5, we have negative 7. By the way, this is directly answered here. So negative 3x squared minus 7 is the answer of f composed with g of x. Then since we are asked to find f composed with g of 3, so we will, this time, we're going to copy this operation, but this time, the value of x will be 3. Okay? So we'll copy this one, negative 3. Every time we encounter x, we are going to replace the value with 3. So you have negative 3 times 3 squared minus 7. 3 squared is 9. 9 times negative 3 is negative 27. Minus, copy minus 7. The answer is negative 34. Okay? So I hope that everything is clear so far. Let's proceed. How about method 2? So actually, you have two options. Whichever you think you are more comfortable with. Okay. You may need to evaluate a composite function for a particular value of x. So for instance, you have here f of x is 5 minus 3x and g of x is x squared plus 4. Find f composed with g of 3. Okay. Method 2, you have to substitute 3 into g of x. So first, you're going to substitute the value, your value into f of x. You have here, substitute 3 into g of x, then substitute the value into f of x. So we'll do first the g of x, which is, you have f composed with g of 3. So we'll focus first on the g function, wherein we're going to substitute the value of x with 3. So you have g of 3, g of x is x squared plus 4. So you'll have x squared plus 4, then x will be substituted by 3. So that becomes 3 squared plus 4. And 3 squared is 9. Then 9 plus 4 is 13. Then afterwards, whatever the result here of the g of 3, we're going to use that as our f of x. That becomes f of 13. So f of 13, we're going to copy this one, 5 minus 3x. Then, wherever we encounter x, we're going to replace that with 13. So that's 5 minus 3x. You copy 5 minus 3. And then our x will be 13. So, negative 3 times 13, that gives us negative 39. Then 5 minus 39, that gives us negative 34. So that's the answer. Okay. Let's proceed. Now suppose f of x is equal to x squared plus 3. G of x is equal to 4x. Let's try. F composed with g of x is equal to f of g of x. So plug the g formula in for x in the f formula. So you have f of 4x is equal to, remember you are asked to find f of g of x. So copy first x squared plus 3. Then every time we encountered x, we will replace that with the g function, which is 4x. So you have f of 4x is equal to 4x squared plus 3. 4x quantity squared is 16x squared. Then just copy plus 3. So this is now the answer. Okay. Let's have the other way around. Plug the f formula in for x in the g formula. You have g composed with f of x is equal to g of f of x. You have g of x squared plus 3. Okay. This is our f function is equal to 4x. So our g function is 4x only. So you'll just replace x with x squared plus 3, our f function. So that becomes, you just simply distribute 4 times x squared, that is 4x squared, and 4 times 3 is 12. Okay. See, they have the same result if we're going to do the other way around. I hope that everything is clear with composition so far. Recall f of x is equal to x squared plus 3 and g of x is equal to 4x. So this is what you're going to do. So if we have here g composed of f is 0, for example, if we are going to plug it with 0 first to our f of x, our function f, x squared plus 3, meaning it becomes 0 squared plus 3, which give us the resulting 3. Now for g of x, we're going to use the result 3 for g of x. So that becomes, every time we encounter x, we'll replace that with 3. So g of 3 is equal to 4 times 3. That's why we have 12. Okay? So this is how we actually solve it. Okay. So to elaborate furthermore, or elaborate more about composition, we have here the fifth operation of functions is called composition of functions. A composition of functions is a function inside of a function, or a function in another function. The notation used for composition of function is this one. Again, this is read as f composed with g of x, or f composition g of x is equal to f of g of x. So to calculate a composition of function, we will evaluate the inner function and substitute the answer in the outer function. Now this is shown in the following example. So we'll have more examples. If we have a of x is equal to x squared minus 2x plus 1 and b of x is equal to x minus 5. So considering these are your given functions. Find a composed of b of 3. Okay, so I have introduced with you and I have given you more examples already before about how to do it, but this time we'll have more examples. If we have a of b of 3, evaluate the inner functions first. So b of 3, our b of 3, you have b of 3, we have x minus 5. We'll replace that with 3. So 3 minus 5, that gives us negative 2. After that, we're going to write a of x. A of x will replace the value of our x, which is negative 2. So you have a of negative 2 is equal to, you have here the a function is x squared minus 2x plus 1. Then we're going to replace x with negative 2. So that becomes negative 2 squared minus 2 times negative 2 plus 1. So the quantity of negative 2 squared, you have positive 4. Negative 2 times negative 2, you have positive 4, copy plus 1. Therefore, a of negative 2 is equal to 4 plus 4 plus 1. You have positive 9. Okay, let's proceed. What about f of x is x squared minus x and g of x is equal to x plus 3. Okay, rewrite as a function in a function in function. Find f composition g or f composed with g of x. So f of g of x, replace g of x with x plus 3. So you have f is of x plus 3. Replace the variables of f with x plus 3. So x plus 3 quantity squared, because we have here x squared minus x. So every time we encountered x, we are going to replace that with x plus 3. Okay? Because that is our g function. So you have x plus 3 quantity squared minus x plus the quantity of x plus 3. Then we're going to use FOIL method or distributive property. You have multiply its x plus 3 by itself twice. So you have x squared plus 6x plus 9 minus the quantity of x plus 3. Copy x squared plus 6x plus 9. Distribute the minus sign. Here in this parenthesis symbol, we have minus x minus 3. Then afterwards, we combine like terms. So copy x squared. 6x minus x is 5x. 9 minus 3 is 6. Therefore, the answer of f of g of x is x squared plus 5x plus 6. Okay, let's proceed to another example. If we have f of x is equal to x squared minus x and g of x is equal to x plus 3. So find g composed with f of x. So rewrite as a function in function. So g of f of x, replace f of x with x squared minus x. So it becomes g of x squared minus x. Okay? Then, go back to the g function, which is x plus 3. Then every time we encounter x, we're going to replace that with our function x. Therefore, we have x squared minus x plus 3. So x squared minus x, we're going to take out the parenthesis symbol, x squared minus x plus 3. We could no longer combine, the three terms are different. They are different. So, we're just going to copy. We have x squared minus x plus 3. So, this is now the answer. Okay. So, we have here, you have to take note. We have here the world view note. The term function came from Gottfried Wilhelm Leibniz, a German mathematician from the late 17th century. So it came from him. Okay? So we are going to give credit to this German mathematician. Okay, let's proceed. So at this point, I think you are now ready to answer. Okay? So answer the following indicated operations. Number 1. G of n is equal to negative 4n minus 4. H of n is equal to n squared plus 5 plus n. Find G composed with H of n. Number 2. H of n is equal to n squared minus 5. G of n is equal to negative 4n plus 5. Find H composed with G of n. Number 3. G of a is equal to 3a minus 4. Find G composed with G of a. Number 4. H of n is equal to 2n plus 2. G of n is equal to 2n. Find H composed with G of n. Number 5. F of n is equal to negative 4n plus 1. G of n is equal to negative 2n minus 5. Find F composed with G of n. Number 6. H of a is equal to 2a plus 3. G of a is equal to a squared plus 2a. Find H composed with G of 1. Number 7. F of t is equal to 2t plus 5. G of t is equal to t cubed minus 2t squared. Find F composed with G of 0. Number 8. G of a is equal to negative 4a minus 3. F of a is equal to a squared minus 5. Find G composed with F of 1. Next, number 9. G of a is equal to 4a. F of a is equal to 4a minus 4. Find G composed with F of 3. Number 10. G of x is equal to negative 3x minus 4. H of x is equal to 2x plus 1. Find G composed with H of negative 5. Number 11. F of a is equal to 4a minus 1. G of a is equal to negative 3a squared plus 5. Find F composed with G of 4. Number 12. G of n is equal to 3n squared plus 4n. H of n is equal to 2n minus 5. Find G composed with H of 4. Number 13. G of n is equal to n squared minus 3n. H of n is equal to 4n plus 4. Find G composed with H of 0. Number 14. G of n is equal to 4n. H of n is equal to 4n plus 4. Find G composed with H of negative 7. Then let's have number 15, last number. F of t is equal to t plus 3. Find f composed with f of 5. Okay, so that would be all. You're going to answer that in your math activity notebook. So you have 15 items all in all. And I hope you understand something in today's video lesson. So to end this video, let's have a math code. This is from Archimedes. And the code goes this way. There are things which seem incredible to most men who have not studied mathematics. So that would be all. Thank you so much for watching. I hope you learned something from today's video lesson. And please don't forget to subscribe my channel. Bye!